Hi, good afternoon, good evening, good morning, everyone. Welcome to DevOps Interview Preparation webinar conducted by Edureka. Myself, I am Pradeep. I have been working with the IT industry for almost 15 years. I have DevOps experience for several years. I've been working on various different projects. I've seen multiple organizations transitioning from a classical background to a DevOps practices. And I'm already part of various transition programs and transformation programs for DevOps. This is a privilege for me to give you this webinar. So we'll start with the first one, which is demands of DevOps. Why we need actually DevOps. What is actually trending on DevOps? What is driving factor for DevOps? So two primary concepts. If you see the first one, team collaboration, agility. Code is deployed 30 times more frequently. All these three different boxes are basically talks about the agility or the speed of the deployment. So it's actually concerning the speed. So code is deployed 30 times more frequently nowadays than the usual. So that's actually possible by DevOps. So if you have DevOps practices in place, agility is possible. You can deploy code 30 times more frequently. And the next one is talk about reliability or the quality. That talks about 50% fewer failures of new releases. Adopting DevOps practices and principles, you can reduce the failure rate of new releases to 50%. So both agility and the quality can be maintained by using DevOps practices. We'll see DevOps market. The DevOps is actually trending nowadays. So according to the recent research, the market rates, the DevOps market is growing to 20% every end of the decade, which is actually a huge number. So if you see, it started in 2012 and it's with very bare accountable numbers, and then the numbers have been increased ever since 2015, 2016, and the tremendous growth is expected upcoming years. So it's actually a good opportunity for the DevOps professionals. And the DevOps practitioners are also paid very well. If you see on the US, it's actually the starting salary is around 100,000, between 120,000 USD per annum, which is actually quite good. And also DevOps practitioners are paid very well in UK and Australia. And some of the parts I know, like UAE that I work with, they also pay very well, almost close to the UK salary. And also some of the places like, Singapore and, Hong Kong, they're also trending a lot. So if you see, like, the markets are trending quite well, the practitioner, DevOps engineers, like DevOps engineers, senior DevOps engineers, DevOps leads, DevOps architects, all these various roles are coming. AWS cloud engineers, cloud support engineers. Multiple organizations are starting various new roles for DevOps practitioners with very good salaries background. So, and it comes to the adopting DevOps by various organizations, we only don't know, according to the recent survey, we only don't know 77% of the organization what they are doing, but the rest of them are actually, most of them are adopting DevOps company-wide. So the organization is actually moving towards DevOps, and some of the organizations, like 31%, is actually adopting for a particular business unit. For example, I work on an organization where my business unit right now is trending towards DevOps, and some project and teams are also independently adopting DevOps, like they have their own DevOps tools, DevOps practices, and etc. And 12%, they are not adopting DevOps, but sooner or later they will probably go for DevOps because it talks about speed and the agility and then the best quality. So there is actually quite a lot of growth that the organization can expect adopting DevOps. So today we're going to discuss some of the basic interview questions. Again, these questions are basically covered on a very high level, and to have a more depth of understanding of each topic, you have to enroll to DevOps class that provided by Edureka. We're going to see some generalized questions and questions based on topics. So these questions are actually divided into various topics. So general questions are actually applicable for anybody, like project managers, developers, QAs. These questions will address, like, what is DevOps and what is the need for DevOps, what is the driving factor for DevOps, and etc. And some more internal concepts, like what are the source code management questions, continuous integration questions, and configuration management, and continuous monitoring, containerization, virtualization. This has been divided into several subgroups, and And most of these questions are relevant for anybody. It's not just a developer or DevOps engineer. It can be for developer or project manager or a project lead or somebody who's actually in the management or somebody who's just starting the career. Irrespective of the level, these questions and answers are applicable for any of the person who's actually venturing his career into DevOps area. So if you see on the left side, there's a small picture about the SDLC. So it starts with the planning stage. And then once the project is planned, then we actually code and build the code, test the code, release the code, deploy to environment, and start using that code application, and then keep monitoring. So this is actually a general SDLC lifecycle, and various tools are basically used for each of these phase of the SDLC. So if you leave the planning stage out, then you start with coding. So once you start coding, you just need to store that code in a repository, in a version control system. So for that purpose, you can use Git or SVN subversion. Now, Git being the popular modern version control system, we're going to cover some of the topics about Git today. And Git is the source control management system or source code management system or version control management system. All these terms are pretty much interchangeably used, and it's actually used to store the code that you're actually writing. Now, once the code is written, so basically we also use a tool called Jira. Now, Jira is basically to track, it's called a issue tracking tool, or it can be called as a defect tracking, or it can be called as a requirement gathering tool. So this tool basically used to track the development activities. So for example, you want to develop a project, and you want to develop a small GUI application, and that application development can be divided into multiple tasks. So for example, one of the tasks would be to design a GUI interface with a login ID and password screen. So this can be actually recorded as a task in Jira and assigned to a developer, and then write actually estimated time in the Jira, so that this task can be assigned to the developer, and the developer will start working on that activity, start coding it, and once the coding is complete, he will change the status of that particular task in the Jira as closed or probably development complete or something. So it's basically a tracking of tasks or issues can be done using Jira, and it's actually from Atlassian. It's a licensed tool, but it can be used for free for a small organization like 5 to 10 developers for free. But if it is an organization wide, you need to actually procure the license from Atlassian. Again, Eclipse is IDE, integrated development environment, and it's actually used by developers to write their code into and then compile the code. So if you're writing Java code or .NET code, you can actually use this Eclipse plugin, Eclipse IDE with various plugins, and then write your code and you can compile. It actually shows you the syntax errors, and it helps you to debug and compile. So widely used free open source tool. Also IntelliJ, another option for for the developers as well. Okay, once the code is developed, the next stage is to build the code, and in order to build the code, we use several tools such as Ant being the most popular and being used for, it's there in the market for several years. Ant is basically a build tool. Alternatively, Maven actually is a tool used for Java-based project and very popular and very powerful. Maven, you can actually you can compile your Java builds or any other builds. Alternatively, Gradle is a modern build tool. It's actually has a lot of out-of-box features. For example, with Gradle, you can actually run a build out-of-box with absolutely no code at all. For example, if you want to run a Maven build, maybe you write 100 lines of code. The same can be achieved with 10 lines of code in Gradle because it has a lot of out-of-box features. That's about build. And once the build is done, you need to test the code, and for that you can use the various testing tools. Selenium is one of the testing tool that can be used very well for web-based applications, for GUI testing and etc., for functional testings. And JUnit is basically for unit testing for Java-based applications. So this testing is once it is tested, then you all can combine all these code build and testing in a continuous integration tools. The little man you see here is actually Jenkins tool, and Jenkins is a continuous integration tool. Alternatively, Bamboo is an Atlassian tool for a continuous integration, has a very good features for a graphical interface. It's actually a licensed version, so you need to buy a license for this one. But for Jenkins, it's a free open source, widely used by across all organizations. These continuous integration tools can be integrated with the source code and then build and test phase, so you can automate this building and testing using the continuous integration tools. You also can use it for deployment purpose. All right, the next thing is the deployment. So if you see this one, the deployment is basically before you deploy any code, you need to provision the environment. So you can use Puppet, Chef, Ansible, or SaltStack for provisioning the servers and various instances. And then finally, you can use configuration management principles or practices to kind of make sure those provisioned servers are up to the mark, or has required prerequisite packages installed, has required prerequisite configuration is complete, and so forth. And then you also can deploy using these configuration management tools. We're going to cover each of topic in detail in the next upcoming slides. So once the deployment is done, then your service is in operation. The next thing is monitor. So the monitoring can be done using various tools. So Nagios is one of the widely used open source tool, has very powerful features inbuilt within it. And alternatively, Splunk, Sense, and New Relic are the other applications. Some of them you need to buy licenses for. So this is the whole stack of the DevOps, and we're going to cover in detail in the next topics. So the first topic is generic DevOps questions. Right, so what is exactly DevOps? Now, DevOps, if you ask anyone about the definition of DevOps, each person will actually define in his own way. The reason is because there's no particular definition for DevOps, right? So, but the actual understanding is, if you ask me, I would say that DevOps is actually a practice that actually brings developers and operations and HR and testing and their operations or their activities together in a collaborative fashion using proper process and techniques to achieve the fastest and reliable software releases. And that's what I actually define it for, because the ultimate purpose of the collaboration, of course, DevOps is for collaboration, and DevOps is actually using the right tools and techniques, but the ultimate purpose of the DevOps is to actually give a faster releases with high quality. Right, that's the main purpose, and that's basically where the return on investment is there. Right, so if you break the principles and practices into various segments, so here is a small example. Source code management is one of the area, continuous integration is another area, continuous testing is one of the areas, configuration management, which also has infrastructure as code, is one area, continuous monitoring is another area. All these areas together combined can be called as a DevOps practices. So the next is, how is DevOps different from Agile? All right, so Agile is basically a methodology, all right, and DevOps is basically a practice. Now, the difference is Agile has a methodology. For example, if you talk about Scrum framework, which is a widely used Agile methodology framework, the Scrum framework actually defines a particular processes and rules, right? And all the development has to adhere or fit into that framework. So the Scrum defines the development activities, as a sprint, repeatable, iteratable sprints. So each sprint has a number of tasks that actually we define. So there are some framework defined in the Agile methodology, and then development practices will fit into that framework. So that's simple. And Agile, say for example, framework or methodology only deals with development. So it's development start and development end. It doesn't deal with how you have to test it, how you have to release the code, how the operations and production support will ongoing support will continue. It doesn't talk about that. But whereas DevOps talks about the whole end-to-end SDLC lifecycle, starting from the development, testing, operations, and production support. So it actually covers quite a lot of wide topics, and it is not a framework where you actually, or it's not just a methodology, it's actually more of a practice, and each organization has its DevOps practices defined uniquely for each to meet the needs of the organization. Right, so it's different. It's quite different from Agile methodology, right? So it's not a methodology; it's just a practice. Okay, so what is the need for DevOps? Why we actually need DevOps? So some of these examples. Let's see. The first thing we have seen, increased deployment frequency. So we have seen the first slide where it says 30 times more frequent than the usual requirements. So if you see the traditional environments, traditional software companies, they were probably doing 2 releases or 3 releases per year, or maybe 4 releases per year. No, actually the things are changing nowadays, that in order to sustain in the market, we need to respond to the change as quickly as possible. So that means a new change means new deployment and new release. The faster you actually create your product with the changes, ongoing changes in the market, the better return on investment is, or the better benefit for your product. So increase deployment, and only possible by using DevOps principles, not by any means, right? And the low rate of new releases, the number of releases that you're doing actually can increase a potential risk for service failure or release failure. So it can be reduced or lowered drastically by using DevOps practices, right? The next thing is shorten lead time between fixes. So if you identify an issue, how much time will it take for you to fix this, and then how fast you can identify there's an issue, right? This is possible by DevOps practices. And then faster means to recovery in time of a new release failure. So that's possible by DevOps because you're using continuous monitoring. You're actually monitoring the application after your release is complete. So proactively, you actually check whether the application is providing, giving a required results or not. And instead of waiting for, at the end of failure, which will probably cause a potential business or reputational damage for your organization, you actually proactively identify the small issues and the gaps, and then you fix them as early as possible. And that's one of the important factor of DevOps. So continuous monitoring actually deals with this particular topic, right? So increase faster and then reliable software, and then short lead times to fix the issues, and then recovery time is much more faster in the event of an incident or a failure. The next question is, name some of the DevOps tools and how these tools work together, right? So this can be an important question. Like you can put this question in another way, like some person can ask you a question like, you are a DevOps professional, and then the organization has given you the flexibility of choosing the budget and choosing various tools. So if you are the DevOps lead or DevOps architect or engineer, what tools will you choose? So to answer the question is this one. The first thing we start is with a source control tool, and there are various source control tools available. Git is one of the popular because it's the way it works and the features that it provides. So you choose Git. Git is a distributed version control management tool, and we actually see more detailed questions about this Git, but Git will use it for version control, and then Maven you use it for building and compiling your code, and as most of the code is actually built in Java. And so you actually can use Maven because Maven provides out-of-box features for compiling Java code, and then store the artifacts in a proper way. For example, Nexus is one of the artifact management repository solution, and that is very well integrated with Maven. So once you compile, you can actually store the artifacts in a Nexus repository, for example. So all these things has to be integrated with a continuous integration tool called Jenkins. Jenkins is a widely used open tool, so it's actually best in the organization as far as I see, and it has a lot of features and plugins available. Now Jenkins can be integrated with the test tools. Selenium is one of the examples for the web interfaces testing, functional testing, and various other testings involved. So it can be integrated with Jenkins as well. And the next thing is you have actually identified tools for your source code management, your building purpose, and your testing, your continuous integration. The next thing is to deploy this application in a particular environment. So to have an environment ready up and running, you need to have a provisioning system. And also the provisioning system should be capable of deploying the application as well. So for that purpose, you can use Puppet, Chef, or Ansible. These tools can be used to provision the servers and then deploy the application and provide the same consistency. Alternatively, you can use Docker for the microservice applications. So Docker containers provide consistent computing environment through the SDLC. The Docker is basically if you don't need a virtual machine because you're running a small applications like microservices, and then you can actually use it. You Dockerize your application. So Docker is also one of the best approaches. It's not an alternate approach, but it's one of the approaches. So that's actually about the question number 4. The next thing is source code management question. So here we're talking about Git because Git is the most widely used modern software source control management tool. What function Git performs in DevOps? So if you see the SDLC, this is the picture of SDLC. We're talking about planning the project and then start coding it, and that coding, when you start coding it, you need to store that code in a repository, and then you also should be able to share your code with other colleagues of your team. So for that purpose, we use Git to store the code and then share the code with other people in your organization who are working on the same project, and then we can further integrate that source code with continuous integration tools, so that every time you do a change to your source code, it will trigger a build automatically, and then triggers test automatically, and then apply some configuration changes and deploys to an environment, and then can be monitored. So all these things can be further automated. So we can actually use continuous integration. Say every time a commit is made to Git repository, continuous integration server pulls it and compiles it and also deploys it onto the test server for testing purposes. So that's how Git actually performs. Now explain Git's distributed architecture is another question, right? Now how does Git work? So Git is a distributed architecture, unlike SVN. The difference between SVN and Git, if somebody asks, is this one. Git is distributed version control system. SVN is a client-server based version control system. What's distributed version control system? Means the repository which has all the source code can have multiple copies in multiple areas. I will explain that. Now if you see the remote repository or a centralized repository, for example, or you can call it the original repository, is actually the original one, the initial repository, and then each collaborator or the developer actually take a copy of the entire repository into his local desktop or laptop, and then start working on his local repository, commit the changes, and then push the changes to the remote repository, so that other developers, other contributors can pull the changes and then start working on them. So if you see the repository is having multiple copies, right, that's actually the distributed version control system. But when it goes to Subversion, it's a centralized version control system, which means there is a central repository that's available in a centralized server, and then each collaborator or each developer actually copy only the contents required into the desktop, called workspace. It's not the entire repository, it's just the workspace. It's just a view that you can see only certain branch, only certain files you copy into your workspace and then commit the changes. So that's key difference between SVN and Git. Now in Git, how do you revert a commit that has already been pushed and made public? So in Git, how do you revert a commit that has already been pushed and made public? So let's say you have actually using Git, and then you can run git commit, and then you commit the change and you push it. Say, hi Jim, how you want to revert it. So there's a git revert command available to revert the change. So for example, using git commit -m commit message. So the first command commits the change, and then you have to use another command called git push to push the change from your local repository to the remote repository. Now once it is pushed to remote repository, if you want to revert the change, you have to use git revert and then the commit name. So each commit has a hash name to it. You just provide the name and then it'll revert the commit, right? Like I said, the question and answers I actually leave to the end, so feel free to type the questions, and then at the end I'm going to answer all the questions, right? So that way we will not break the flow. Right, the next question is, how do you find a list of files that has changed in a particular commit, right? Git offers various commands. Git diff-tree is one of the commands that we can use to see the files that are changed. So git diff-tree -r, recursive, and then hash. Hash is basically the commit hash. So here the commit number actually is called hash, and because it's just not the number, it's a combination of characters and numbers. So you just take that commit hash and then provide it so that it shows the list of files that have been changed. Now the git diff-tree provides the full list, like the origin, the person, the author of the commit, and the timestamp, and then the commit message, and where's the differences and all. But you don't want to see everything, you just want to see the file. So the next command, git diff-tree -no commit ID, -name only, -r hash. It gives you only the list of files, nothing else, not even the commit ID or the hash, all right, of that particular commit. So it just shows you all the list of files that have been committed or changed in that particular commit, all right? And we go to the next question, which is, how do you squash last n commits into a single commit. Now this is very interesting and very unique feature of Git. In the traditional version control system, once it is committed, you cannot change the history. But with Git allows you to play around with your version history or version graph according to your need. Now, what is squashing? Squashing means combining multiple commits into a single commit. Say, for example, you have committed 4 commits, 1, 2, 3, 4, and you realize that all 4 commits are supposed to be committed in single commit rather than in having multiple commits because you wanted to share that commit ID or the files with somebody else. So for that purpose, we use squashing. This is called squashing. We use git reset command. So reset actually resets the version history. And what it does, see, for example, you want to commit, change, combine all the last 4 commits. Then in that case, you need to use git reset -soft head -n. N stands for the number of commits from the head. Head is the latest, the top. -n means the last n number of commits, which means, let's say, if you give 4, then it's going to be last 4 commits. So once you give this command and then run git commit, so it actually combines all the commits into one single commit. So you have to provide a new commit message. So that new commit that is committed will have all these 4 commits, the files that are changed. So you're basically playing around with commits. So similarly, you can actually do another thing that if you, for example, you wanted to edit, the change, edit the the edit message. So you can use -m and then provide some command, like for example git log -format %b -reverse head. So it's basically you're actually taking the same commit message of all these previous commits and then adding it to this commit, so that you don't want to even lose the commit messages that were committed in the past. So another interesting advanced topic of Git. So that's actually about Git. And we actually now move forward to continuous integration. Now, before actually I continue this topic, I just want to take a look at the question and answers, because I see some of the questions people are posting, and it may be related to this same topic. So let me just open the QA window and see what are the different questions about the Git. Okay, I see there are generic questions I'm skipping. I'm just talking about the Git questions. Can 2 people collaborate in Git without pushing the code into a remote repository? See, if you have to, this question is from Saurabh. So if you have to collaborate your changes, you have to push to somewhere. So for example, either you can push it to the origin, or you can push this change to the other remote repository. So it can be your colleague's repository, so you can push the change, or the best way is actually push it. And there are alternative ways without pushing to the report repository, but you still have to push to somewhere, and that is actually to another local repository. So that's the answer question. So the best way or the solution is to push the code, right? So it's possible, but it's actually a little bit tricky and it will mess up something. Now the next thing is, can we reverse this commit back to 4 different commits? I didn't understand this question very well. Can we reverse this commit back to 4 different commits? So see, the squashing means we can reverse a commit to 4 different commits. I mean, we can reverse a particular commit to any commit that we want to. For example, you have like done a 10 commits and you want to go revert back to 10th commit. That's possible. So you just give a reverse and then give the commit name. So that actually is the answer to the question. So now again, there are some other questions provided by guys like DevOps. Every company requires DevOps. That's actually right. Every company actually requires, if they wanted to sustain in the market, they actually have to be DevOps. I mean, that's what my understanding. Without DevOps, even though some companies, they don't call DevOps, they have some sort of practices. So, somewhere or the other, they are following DevOps. But basically, DevOps talks about more about these topics. So the next thing is, I will actually skip the questions now. If you have any questions, we'll see at the end. I will go forward to the continuous integration topic. What is meant by continuous integration? So continuous integration is defined basically based on the commit that you're doing. So every commit that you do to a repository, or every change that you do, has to be immediately compiled and built and integrated. So that's called continuous integration. So the continuous integration best practices that you do a commit on your own branch, for example, but continuously integrate the change to the trunk or to the master or to the main line of the code, so that it can be compiled immediately, and then the feedback will be given back whether it's been failed or successful. So for example, you're a developer, you're working on one single feature, and for that purpose you created a separate feature branch called so and so, and then you actually done your coding, you have compiled it on your desktop, perfectly fine. But how sure you are that that code actually works with the code that the other developers are actually doing it? So that's actually is what integration means. You integrate your code with other developers, and then that integrated code has to be compiled, has to be tested whether it's working or not. So that's actually continuous integration. So you commit your change, and then you integrate your change to other people's changes, and then you build it and test it and deploy it. So the best practices, if you read the book called Continuous Integration by Jess Humble, which is a very famous book, it actually talks about various best practices for the continuous integration. One of them that I like is that all the code by all the developer has to be committed directly onto the trunk, and then the trunk or the main branch or the master branch, and that master branch has to be integrated with a continuous integration server, for example Jenkins or Bamboo, that actually should pull all the number of commits, and for each commit the build should trigger, and then there should be an automated test that trigger, and there should be a deployment that should be followed by this particular commit. So each commit is actually resulting a build and a test, and optionally a deployment, right? So that's basically is about continuous integration. And then mention some of the commonly used Jenkins plugins. So Jenkins is, our focus is Jenkins here, which is a continuous integration server, and Jenkins will not work without plugins. So by default, if you install Jenkins, it's just the shell. Without installing plugins, you cannot use it. So one of the basic interview questions about, okay, again, the question, this session is basically covering only the basic interview questions, not the in-depth topics of each and everything, because if you wanted to have any questions related to any in-depth or specific topics, feel free to enroll into DevOps course, and where we're going to discuss, several hours on each topic extensively, and all the questions and answers can be very well answered. So some of the plugins that Jenkins uses this Git plugin or SVN plugin, essential because it has to be connected with a source control system to monitor, and SSH plugin, a very basic plugin to log into remote machines to do some remote execution of commands and copy the files, etc. And then build pipeline plugin. So it's basically, build pipeline is actually a dependency mechanism that you can use for to create an upstream and downstream connections. So basically, pipelines basically you can actually build, you can see the entire view of your building and deploying to different environments and staging and production, etc. So for that purpose you can use build pipeline. And then email ext plugin, that's basically to send notifications as soon as you get some result out of a build. And HTML publisher plugin, also to publish the HTML reports. Multi-slave configuration plugin, and this is basically to allow the administrator to configure slaves. Slaves are basically the agents of Jenkins agents to run the jobs remotely on a remote server, and to manage them you can use multi-slave configuration plugin. And parameterized trigger plugin is another plugin that actually lets you build based on the parameters, so you can pass various parameters during the building phase. And there are several more. I mean, these are just a few plugins, and there are various other plugins, like for example you want to provision, you can use Chef, or if you're probably connected with AWS, you can use AWS plugins. And if you wanted to use, for example, Docker images, you can use Docker plugins and various other plugins. And you can also use some of the basic plugins, such as native plugins of Jenkins, for example, environment dashboard, release dashboard, all the dashboards, and you can use advanced topics like job DSL to kind of manage all your jobs and to script your whole infrastructure of Jenkins as a core. You can use job DSL plugin and various other plugins that can use it. So these are some of the basics. Okay, the next question is explain Jenkins distributed algorithm. architecture. What is the need for this architecture, right? So Jenkins is basically a distributed architecture. As you can see, it has a master server that actually can be configured with all the jobs and the requirements and everything, and then you can actually choose a particular job to run on a different server, right? Why? Because it's because, say for example, you want to deploy a code on a Linux box, and then you want to deploy the same code on a Windows box, for example, or on a different Linux distribution. So for that purpose, you need to connect to that server and then do various activities. So this all can be automated by actually installing Jenkins slave on each of these nodes and then running it. So that's where, and then you have like various environments. Each environment can be treated as a separate combination of separate slaves. So Jenkins master is not just enough. You just need to have Jenkins slave, and you can use as many slaves as possible because it's an open source tool, and you're not paying for this, right? So that's actually the distributed architecture of Jenkins. And the next question is, how will you secure Jenkins? In other words, what are the best security practices for Jenkins? And so the question is, you have to ensure that the global security is a parameter. Again, in the configurations settings of Jenkins, you actually set that on so that not anyone, like anonymous users, can access it. So you're actually restricting anonymous users, and you're enabling actually security, and you can integrate probably very well with your Active Directory of your company. That is also one of the best ways, and actually is a good way of securing your Jenkins. And then the next thing is, you have to enable something called a project matrix in Jenkins, so you can actually choose who can access which project. So that's actually possible by project matrix in Jenkins. All right, you can also automate the setting rights and privileges on Jenkins using custom control script. That's possible, but then you have to do some scripting activity for that one. Also, you can limit the physical access of Jenkins data folder and some of the folders, so only Jenkins user can have access to that one. If you log into the server and then open Jenkins folder, you have something called Jenkins data folder and then jobs folder, and these folders can be used to secure as well. And the next thing is periodically run security audits, and that's one of the things that each organizations do to kind of, it looks like very complicated, but it's not. You just log into server every time and just see who is having access, is there any change in the accesses, or run some script that actually monitors does these audits automatically. Right, so explain how you can create a backup and copy of files in Jenkins. So this is also one of the ways you can also migrate Jenkins from one instance to other instance, right? The same process is applicable. The way that we can do is actually, there's a folder called jobs, and then inside the job directory, all the jobs will be stored. So you probably can take a copy of the whole jobs folder, all right, and that actually takes that means you're actually storing it. Actually, you can copy it or you can clone it in a different machines and then reuse it. So that's basically for migration or changing. Or when you rename an existing job, for example, name, then you have to also make sure that the underlying jobs are renamed. So to answer quickly these questions, take a copy of the jobs folder. That actually does the work. All right, next is configuration management. Before I go to this configuration management, let me take a quick look at the question. So somebody asked, like, what is the meaning of bisect means? See, git command, actually it's used for binary, and it uses some sort of a binary search algorithms to kind of find which commits in the projects introduced a bug. So it's actually a little bit advanced kind of topic, but it's actually, you can use this for finding the bad commits versus the good commits, and etc. So again, this is actually a little bit in-depth topic, and so we're not going to cover all detail of this one. The next thing is on the continuous integration. The question is nightly build a part of continuous integration? Actually, nightly builds are not continuous integration. Continuous integration means you commit, each commit should trigger a build, right? That's actually continuous integration. If you read the book 𝐄𝐝𝐻 clearly says that nightly builds are not continuous integration, right? So that's a famous book. Almost all organizations actually adopted the principles defined in that particular book. So I also vote for that one. So the answer is no. The next question is, what's the difference between CI and CD, continuous integration and continuous deployment? Actually, very good question. There's actually a difference between continuous integration and then the continuous integration and continuous deployment. See, continuous integration is talking about building your code as quickly as possible to get the feedback whether the build is successful or not. Right now, so each commit will trigger a build and then the corresponding tests. So that's actually continuous integration, right? And then the next phase is continuous deployment. Means every build that is run will generate some artifact like a jar file or some sort of file. That particular new artifact, the result of the new build, has to be deployed continuously in an environment to kind of test it, and that's actually continuous deployment, right? And we also have something called CD, also stands for continuous delivery, which means it actually talks about the whole large picture. Like as soon as you build your code, you have to continuously deliver that to production. So it talks about deploying continuous delivery, continuous deployment to your test environments, and then the automated trigger, define a workflow that actually automatically tests the test environment, and make sure if it is done, then continuously deploy that to production. So there are organizations that follows continuous deployment, continuous delivery. For example, Netflix does maybe 30 deployments per day. They do quite a lot of deployments. So the way to the production, so the way they do is each commit will actually trigger a continuous integration build and actually creates an artifact, and that artifact will be automatically deployed to a test environment, and then the test environment will actually the automated tests will run against that environment if they're successful, and it will be promoted to production immediately. So if it is failed, then actually feedback will go back to the developer, and then they will again fix it and go. So this process will goes on. This is actually a continuous delivery rather than continuous deployment. So the next topic is continuous configuration management questions. Right, explain the various configuration management components. Now, this is not a new term, configuration management. So it's basically you're managing the configuration information of each of your resources or assets, right, of your organization. For example, a server is an asset, and each server has its own configuration information, right? And then it has to be managed properly. So the phases of the configuration management is first, configuration identification. So identify what are the configurations for your resource, for example, or asset. So let's say you have a server, and then how many CPUs it has, what is the memory, and how many packages installed, what are the various configuration files of that particular server, and what it is used for, the purpose that it's been used for. So various things. It's been, there is quite a lot of massive information about each node, and actually is the first beginning part is identification, and that information has to be stored somewhere. And in the olden days, we used to call CMDB, Configuration Management Database, where all information is stored. Now with modern things like, using Chef, Puppet, or Ansible, so it's actually quite a lot of things are automated. So if you install these tools, these configuration management tools, they fetch the information automatically and stores into its central server, right? Which is a great thing. So, and then once the configuration identification is done, then you have to manage the change, which is actually change management. And change management is like each change has to be deployed properly and rolled back in the event of a failure. So that's actually configuration change management. And configuration status accounting. So that's what actually it provides a status whether the configuration item is working properly or not, right? And this is used for reporting purposes. And then the next thing is configuration audit, verify the consistency of the documentation against the actual product. Right? These are the principles of configuration management. It's just for the theory purpose, and then when it goes to the configuration management, the actual management of the tools like Puppet, Ansible, Chef, the picture will be a little bit different. Right. Another potential question is, what's the difference between asset management and a configuration management? Now, asset management talks more about money. It's about logistics kind of thing. So, but when it comes to configuration management, we're talking about more from an operations perspective. It's ITIL based, right? It's basically for troubleshooting if there are any errors, right? The life cycle is just to deploy and the retirement. Right, but when it comes to asset management, it's concerned with finance, like how much it will cost, and who owns it, and then what is the purchasing and leasing processes terms, and also how to maintain the servers, and etc. So it's basically licensing, and all these things will be part of this particular asset management thing. Whereas configuration management is about deployment and operations, right? So that's a difference, key difference. Okay. The next thing is, as part of this, what do you understand by infrastructure as code? Now, infrastructure as code has been very popular. In fact, DevOps, the whole practice of DevOps has been, or the DevOps evolved from the principles of configuration management and the infrastructure as code. So what does exactly means that your provisioning an environment should start with a code. So if you wanted to provide a provision, a dev environment or a tester production environment, everything should be starting with code. So it should contain a code. You have a code and you trigger the code that will actually deploy or provide an environment. So it's basically you're storing the infrastructure as a code, right? If you see the definition, it says IAC is automation of IT operations such as build, deploy, and manage by provisioning of code rather than the manual process, right? So you provide dev, test, and production environments using the code on a centralized location. That's the infrastructure as code. The next question is, what's the difference between push and pull in configuration management? Now, why we need actually push and even pull during the configuration management is basically your centralized server actually stores the configuration information of all your nodes. Like, you know, what your node A contains, node B contains, node C contains. Now, if there is a change that a node needs to receive, then there are two mechanisms that would be involved. Either the centralized server can push the change to the required node, that's actually push mechanism, or the nodes, we can define a polling mechanism so that the node will consistently checks with the centralized server and then updates it whenever there is a need, right? So that's actually pull mechanism. Now, why we're actually discussing this one, because there are some tools work on a push-based mechanism. Some configuration management tools work on pull-based configuration management. For example, Ansible uses push method, and other tools like Puppet, Chef, and SaltStack uses pull-based mechanism, right? So the next thing is how Puppet works, right? Now, Puppet actually has a master and slave concept. So you have a master server. It's a centralized Puppet server that will be used for your storing all your configuration information about all your Puppet slaves. Now, Puppet slave is actually a node where you probably running an Apache or some kind of an application or database or something. So you actually manage those servers from the Puppet slave. So you install Puppet slave on the nodes, and then you install Puppet master on a centralized server to manage your changes. So the first thing is how it works is the Puppet slave, when it is connected through SSL encryption, right? All the slaves are connected to master using SSL, secure layer, secure socket layer. So now the first thing is the Puppet actually slaves sends the facts. Now, what is fact? Fact is basically the configuration information, everything about that slave, like CPU, number of CPUs, memory, number of packages installed, and quite a lot of massive information will be sent to Puppet Master. Puppet Master stores it. And then Puppet Master also has a catalog information which actually sends to slave. This catalog is number of packages that needs to be installed, and so or number of configuration changes that needs to be done on a particular slave. So slave actually compares the catalog information, see if there is a deviation. Say, for example, there's one line that needs to be changed in a conf file, right? So in that conf file, one line information needs to be changed. So Puppet slave identifies this change, and then it actually does the change once the catalog is pushed from the master server, and then it reports back the results, right? So the number 3 says the node reports back the Puppet indicating the configuration is complete, which is visible in the Puppet dashboard. So that's how actually Puppet works. Right. Now, what are the modules and manifests in Puppet? So there are two things about modules and manifests. So manifest, let's talk about on the right side. What is manifest? Now, the configuration information of a particular server or a Puppet node is actually stored in a native language called Puppet native language. And these information are actually stored in manifests. So, for example, you need to install an Apache on a particular server. So that's actually a line called Apache, right? So this manifest actually contains the lines of code to perform some activity on a node server. Now, module is actually a combination of such manifests, right? For example, you can have a manifest to install Apache, another manifest to install MariaDB, another manifest, let's say, to install Tomcat. So all these combination can be combined together and as a single module, and this can be reused. So the module, so if you see on the left side, a Puppet module is a collection of manifests and the data such as facts, files, and templates. and they have a specific directory structure. Modules are used for organizing Puppet's code properly, and because they allow you to split your code multiple manifests, and you can actually choose which manifests to use from a particular module. So it's actually like, you know, you're writing a Java project, like you're writing each module. So manifests are basically single individual files, and they are written in Puppet language called extension is with pp. Right? So if you see the small example, it says node host2, which is basically to install this on node host2, Puppet slave called host2, and you're calling a class called Apache, and then that Apache, you're defining various parameters, like, you know, that Apache host module, you're calling a module and then defining, you know, the name is example.com, and then you're actually passing some parameters like resource port is equal to 80, and then doc root is equal to where www.html. So it's a small example. Another thing to note is like forge.puppet.com. It's actually a community, to open source community, where people develop their Puppet modules and then they share with each other. So it's a good place to go and look for Puppet modules. Instead of writing your own, you can actually choose one of the existing Puppet modules. Okay, now the next thing is Chef. Let's talk about Chef and how the architecture. Explain the Chef architecture. Now, the three key terms for the Chef is Chef server, Chef node, and then Chef workstation. Three different things. Now, Chef server is like Puppet server. It is a centralized store of all the infrastructure as configuration information. So stored in Chef server. And then the Chef node is basically what Chef server manages. So Chef node is basically your server where Apache or whatever is installed, your application is running, and you want to manage those nodes with your Chef server. Right now, alternatively, with Chef workstation is actually your desktop or a server, a virtual box, from where you actually initiate Chef commands. Right now, knife is actually one of the commands that we use to upload configuration changes to the Chef server. So, for example, you want to change something called a cookbook. What is cookbook? Cookbook is basically a place, or actually storing the configuration information, all your configuration templates and files and everything on a target in a cookbook. So for example, you can write a cookbook. Cookbook is a code you write in Chef DSL language, which is actually a Ruby style, and in the cookbook you actually define what packages needs to be deployed into a particular Chef node. So you define, and that creates a cookbook. That cookbook has rules, number of packages required, and the services needs to be started, everything combined together in a cookbook. And that cookbook you have defined, and you wanted to store that cookbook in the Chef server. So you use knife upload command, right? So that command you use from the Chef workstation. So you do operations like changing the Chef server information using Chef workstation. And then Chef actually server pushes that information to the Chef nodes, right? And see, if you see this here on the left side, it says Chef client runs on node, retrieving configuration information from the Chef server. And Chef client and knife uses API clients to talk to Chef server, right? And knife is used to communicate with nodes using SSH. And systems managed by Chef are called nodes. On the left side, it says Chef workstation is simply a computer with a local Chef repository and a properly configured knife command. So this is how it works. Now, if you just on the right side, you see all configuration first tested on the workstation. So if you write a cookbook, you have to test it. So you can use Chef Inspect or Chef kitchen testing tools to kind of test it on your workstation, and then you push it to the server. And then the Chef server actually manages automatically pushing the information to the Chef nodes, with some process called convergence. It uses to kind of make sure the changes are actually properly pushed, or the state of the Chef nodes is in line with what is defined in the Chef server, right? That's actually the architecture. Now, just an example, to write a recipe to install HTTPD and copy index.html file to the default document root to confirm the installation. So a small example, probably somebody will ask in interview. See, it's very easy. So recipe, there's a difference between recipe and the cookbook. A recipe is basically just like a manifest. It contains the resources to bring the server into a particular state. And then when you actually combine the recipe with all the templates and variables and all, it can be called as a cookbook. And there can be various recipes. So together you can combine several recipes as a one cookbook. So just like, manifest is equal to recipe, and then module is basically like a cookbook. So in Puppet, you call module in Chef you can call it as a cookbook, and in Puppet you call manifest. The same thing you can call as a recipe in Chef. Right, so here package HTTP. Now package is basically a resource. It's called a resource in Chef, and it's a predefined resource. And when you define package HTTPD, actually it'll install a package called HTTPD. And service is actually called another resource that actually starts a service, or actually stops a service, or enables. So you can actually define do and end. Do is basically like open brackets, and end is like closing brackets. And you actually define an action. Right, so if you don't define an action, so by default there is some action associated with that particular resource, and that will be enabled. For example, you're mentioning here action enable comma start, which means you are enabling the service called HTTPD, and then you're starting the service. So if you don't define, so by default it actually automatically starts, because for service action start is default. Right, we're going to see that later. And the next is you're using a file resource to copy a file to this target where www html index.html do open brackets content. You're writing the content into that file as welcome to Apache in Chef. So this is basically test, and then end it. It's a simple kind of a script. All right, so the next thing is what happens when you don't specify a resource's action. So like I mentioned, so for example, let's say the first example is file c users administrator chef report settings.ini do content green is equal to hello world. So you're actually basically not specifying any action. But whereas if you see the next snippet code, it says action colon create, which means both does the exact same thing. It creates a file called settings.ini, and then with a content called greeting hello world. But the next thing is you're explicitly specifying an action called create. And now if you specify action called create, it actually creates. Even if you don't define, action create is a default action for file resource. So that's why it actually gets executed. So because create is the file resource's default action, so it creates it. Another intro question. So the different question is, are these two chef recipes are the same? So what is the difference? The first one is starts with package HTTPD, service HTTPD do action enable start end. The next one is it starts with service instead of package, and then it's starting a service called HTTPD, and then later it's running package HTTPD installation. So by seeing at this, the way the chef works is it works sequentially from the top to down. So the first one is correct because it installs the package and then starts it. The second one is incorrect because it's starting the service and then installing the package. So, but that's wrong. You have to install package first in order to start the service. Otherwise, it'll fail. It says the package does not exist. So the first one is correct. So the answer is no, they are not, because the chef applies resources in order they appear. So the first recipe ensures the HTTP package is installed, and then it configures the service. The second recipe configures the service and then ensures that the package is installed, which is actually incorrect. Right, the next question is about Ansible. Is Ansible a push-based or a pull-based CM tool? Like I explained before, Ansible works on a push-based mechanism, not a pull-based. Now, how does it work? You have a server, Ansible server, where you have actually kept all your playbooks, right? And then those playbooks can be version controlled, right? And then all we can do is actually what Ansible does. Ansible, you have to specifically write a Ansible commands to push these changes to the various other nodes that you have. And then by default, Ansible uses SSH to connect to these remote servers that you're managing. All right, and then the other intro questions, the famous intro question is that you don't need to install Ansible agent on each of these nodes that you're managing. There's no such thing called Ansible agent. There's only one thing called Ansible server. You install Ansible and that Ansible on a server, right? And then as long as your server is able to connect with SSH and run remote commands or using SSH onto the remote box, your server can manage it. All you need to do is you need to configure your inventory, which is basically the number of hosts that server is managing properly in the inventory, right? As long as you can do that, it can actually manage it. So that's actually a difference between also push and pull mechanism and also the way Ansible works. The advantage with Ansible is you don't need to install an agent on each box. So a quick intro question can be, another intro question can be like how, let's say you can be asked like, you have 50 different Linux boxes, and then you're able to do SSH from your box to all these 50 new servers, and then you want to install a particular application on all these boxes. How can you do it? So the simplest thing to do is, to run Ansible, it can be one command, to install, like say, Apache on all these nodes. You just write a small playbook. Now here, the cookbooks and Chef is actually same as playbooks in Ansible. So we call playbooks in Ansible. So you write a small playbook that actually installed Apache, and then run Ansible command and specify a number of hosts, and that actually connects via SSH and installs that HTTPD package, and then reports back the status or the update about how it works. The next thing is how Ansible architecture looks like. Right. So as I mentioned, like Ansible inventory is basically the hosts, the number of hosts that you're managing, and then it has something called a playbook. Now playbook is the same as like cookbook. Playbook has modules and then APIs and plugins, right? All these things. So each playbook, uses some modules, it uses APIs, and each uses plugins. Now playbook is basically code that you write and that calls these various existing predefined module, right? And then Ansible Automation Engine has, you run the playbook against an inventory. Right? You define a playbook to install Apache, for example, and then run that playbook against an inventory. The inventory can be a UAT service or development boxes or production service, right? And CMDB is actually connected, which is configuration information, and then all the hosts that it manages. So this is a simple, very simple architecture diagram, right? All right, before we go to the next topic, I want to take a look at the questions. I see several questions here. Questions about, is Ansible only uses push mechanism? Ansible, yes, uses only push mechanism as far as I am aware, as my understanding goes well, right? And I have heard it can be used for pull mechanism as well. Probably yes, Saurabh, but I have not used it. And the popular way of using Ansible is push. So we're talking about here, not a tricky question, but interview questions, right? We're talking about interview questions. So if an interviewer asks this question, he probably is expecting push from you, right? But if you wanted to say it can also use as pull, then you have to prove it. What is the plugin, exact plugin that uses. My experience, I have not used Ansible for pull purposes, right? I have only used for push, and that's the most the people use Ansible for, and Ansible is famous for push. Your answer should be push, right? We're talking about like, tracking interview questions. Sometimes you're probably more wiser than the person who's interviewing, but you just need to answer your question accurately what the guys are actually asking you. So that actually gives you success in the interview, right? And then the next question is, what's the difference between tools like Chef, Ansible, Puppet, and Docker? So Chef, Ansible, Puppet, they are configuration management tools, like to manage the configuration. Say, for example, in the olden days, just an example, like I used to manage like various environments, like 10 development environments, 10 UAT environments, 10 production servers, like, environments like dev environment has 10 servers, UAT has 10 servers, production has 10 servers. Now, each of these 10 servers has its own role. For example, in the 10 dev environments, one server is used for the web application, the other one is used to run some backend services, the other one is a database server, and then we have a cluster of all these things, like each is done on a redundant basis. Now, all this is good, actually, it's a very good infrastructure. But what happens is, when we promote code, deploy code from one of these environment to another environment, the deployment is successful, but we have some issues. So deployment goes smooth, but after starting the service, some things doesn't work. Some of the issues we used to encounter, and this is a repeated problem. Why? Because the configuration of each of these environments are not identical, right? Which means there is somebody has done some small change to an Apache file, or changed a registry entry in the Windows, or probably changed a fine-tuned some memory parameter in, let's say, in the database, right, of the server, and as a result, the development, everything worked fine. But when it goes to the UAT, it didn't work, because that small information, the configuration change, has never been recorded anywhere, right? And for that purpose, to manage the consistency between all the environments, we use configuration management. Why we do it? Any change we do it using either, if you're using Ansible, we actually do it through playbooks, which is again stored in version control. If you're using Chef, we do it using cookbooks. And Puppet is actually Puppet modules and manifests, right? So that's how we use. So that we actually we provision environment, we deploy the playbooks, all these configuration information to the new environment or to the existing environment, so that it'll be automatically updated. It match with exactly what we need. right? So that there will not be any failure at all when we actually deploy the actual code, right? So that's the purpose of the configuration management tools. Docker, on the other hand, it's actually used for virtualization purposes, right? So there's a slight difference between virtualization and Docker. We're going to cover that topic about Docker in the next upcoming slides. Right, the next question is modules used for defining a classes. Can we deploy a module directly on the Puppet agent? Yes, we can actually deploy a particular module directly on an agent, right? So now a module can have a default class. So basically every module should have a class. And if you don't specify a class, it actually takes a default class. So that module you can define, you can actually run against a Puppet agent. That's possible. All right, the next question is, for provisioning infrastructure on a cloud, which tool is better, Puppet or Chef? Both are equally powerful. So in order for me to comment, it's very unwise. It depends upon the person's interests and then the person's experience. So for example, if you're more experienced with Puppet, you can use Puppet, because even the licensing costs are more or less the same. Puppet, if you're using, for example, AWS Cloud, I can just give you an example. AWS Cloud has OpsWorks tightly integrated with Chef, right? So probably your default option would be to choose Chef if you're using cloud. But Puppet also equally powerful. You can still use Puppet to provision, AWS cloud. Most of the people I use with, those who use OpenStack, they actually use Puppet widely. So just how you work with. So my understanding is Puppet goes well with if you're using OpenStack, and Chef goes well if you're using with AWS. Again, it's just the default, but you still can reverse it and it works exactly the same and even much better sometimes, right? Okay, is install is a default action? Yes, it is. Install is a default action for package resource, right? Now, which is better, push or pull mechanism? Well, actually it depends. So for example, from case to case. So if you want to do one-time activity, right, you want to install provision servers, and then using provisioning servers can be done by push mechanism because it's a one-time activity. But pull mechanism is to kind of, once you're provisioned and then it's connected to an environment and you have to keep on receiving the updates, and for that purpose you can use pull mechanism, right? The next question is, it can be done by creating Docker images and uploading it onto the Docker. I'll come back a little bit later in our last section called virtualization. All right, the next topic is about continuous monitoring. Now, why continuous monitoring is necessary? Continuous monitoring allows the timely identification of problems and weaknesses in the software that we actually deploy, and it actually reduces the expenses of the organization, because you're finding the issues earlier than after an incident is happening and a financial or reputational damage of a particular organization because of the service failure. So you're identifying the potential failures in advance rather than in after some time. So it's being proactive. So this is done by solutions. This solution addresses continuous auditing, monitoring, and transaction inspection. You're inspecting certain things. Now, why we need continuous monitoring? And that's what we have seen. What does Nagios work for? So we're going to cover here Nagios. How does it work? So Nagios is a open source monitoring tool, and this open source monitoring tool is used for monitoring your various applications. And basically, Nagios, it actually is a server. It runs based on centralized the Nagios server. You actually install the Nagios server module in a particular server that's actually used centralizedly to monitor all your applications, all your servers. So it's a server agent-based, client server-based application. And this Nagios daemon actually has a processor or a scheduler. It has a scheduler that actually sends the results on or executes the plugins on a scheduler basis, on a recurrence basis. So basically, what you do is you install the Nagios server on a Nagios server, so that you can monitor the local resource, like all the CPU, memory, all the information, monitoring of the service information about the particular server. And you also can use something called a remote server management. So using a Nagios server, you can also manage remote agents. And for that purpose, you need to install another plugin called NRP, which we're going to see in the next slide. So basically, Nagios comes with quite a lot of plugins. So, right, you can use by default Nagios when you install basic module contains nothing. But when you install plugins, now each plugin performs various actions. So you can have a plugin to monitor the CPU usage. You can have a monitor to plug in the disk space. So all is plugin based, right? So you need to install Nagios processor, a scheduler, or a server, and then you need to install Nagios plugins, right? That will be executed by this processor, and then that actually gives you the information, right? So the first thing is Nagios executes the plugin. The next thing is plugins checks the status and gets the result. And the third thing is plugin sends the result to the Nagios to process. And then Nagios actually finally displays that information in a web GUI interface, right? And then these plugins can be a local plugin. All this plugin can also execute it on a remote box. If you see second number 2 here, plugin checks the status and gets the result of a remote host, right? In order for the remote host to work, we need to have another plugin. We're going to see it in a second. And notifies admin. Number 4 is notifies admin about the status processed by the scheduler. So notifications can be sent either by SMS or by email. So in order to manage the remote host, which is very important, you have to install something called Nagios remote plugin executor, right? So this remote plugin we have to install on a remote box. For example, here you see a remote Linux or a Unix host where NRP is installed as another package that we install. This monitoring host, which is a server, Nagios server, actually runs a module called check NRP, and that check NRP actually connects using SSL to this NRP service, which will monitor various information like check disk, check load, check HTTP, check FTP. Now all these check disk, check load, and all they are plugins installed locally on the local box. And then here we have installed a NRP plugin. And then on the remote box, we have a check NRP plugin, which actually connects to the NRP and then pulls the information about the remote box and then shows it on the web interface. Now, okay, this is actually a concept for Nagios to understand in depth. We need to actually install and then do some hands-on, right? But these questions kind of can give you some kind of an understanding. And if somebody asks you about Nagios, and if you have not worked on Nagios, probably the best thing is you can just say that Nagios server has to be installed on a server, and with the right plugins, that plugins will actually be run and then gives the information about the CPU or a memory and stuff, and then can be displayed on the Nagios web host. And similarly, to monitor the remote host, you need to install a plugin called Nagios Remote Execution Plugin. By that, you can actually know the status of the remote box, right? Okay, what does Nagios check for external commands, right? Now, Nagios check for external commands under the following conditions at regular intervals specified by command check interval options in a main configuration file. So actually you can set up a regular intervals command check interval option and then configure some kind of a, for example, 30 minutes or 40 minutes, that actually then Nagios will check for external commands, the intervals, and also immediately after event handlers are executed. So when certain event actually handlers are executed, you can set up check that to run the external commands. And this is the condition to regularly recycle the commands checks, and is done to provide immediate action even if the handler submits commands to Nagios. All right, we'll move back to the next question. What is the difference between active and passive check in Nagios? Now, actually, the major difference is active checks are initiated by Nagios, while passive checks are performed by some external applications. So you can probably have an application that actually wanted to pull some information or do some checks through Nagios. So you can actually initiate actions or checks by third-party applications, or that's called passive checks, and your Nagios can do the checks that's actually active checks. Now, passive checks are useful for monitoring services that are asynchronous in nature, which means it cannot be monitored effectively by polling their status on a regular scheduler basis, right? So what happens is that Nagios, you can specify an interval in the Nagios server that can check the status of a particular service on a regular interval. But what if your application doesn't depend upon that regular interval, but it just needs whenever there is a need basis? So in that case, you need to use passive checks. And also, if there are servers that are located behind a firewall, which means your Nagios will not work, so in that case you also have to use the passive, another monitoring host to kind of monitor do the passive checks. All right, the main feature, active checks are initiated by Nagios, and the active checks are runs on a regularly scheduled basis. There are two important questions like Active checks means initiated by Nagios and then run on a scheduler basis. Passive checks means initiated by some other application in the event of where you don't actually rely on the scheduled information, right? Flap detection. So what is actually flapping? Now flapping means flapping occurs when a server or a service or a remote host state is changed very frequently. So it becomes red, it becomes green very frequently. So you're actually confused what exactly it is. So it's basically it's becoming red one time, it's becoming green, becoming red, green. So that means it's actually very inconsistent. And how does Nagios deal? Nagios deals it's slightly different. Actually, it stores the last 21 checks, the results of the last 21 checks in a service, analyzing the history checks of the results. So it's basically it restores the last 21 checks of the host or a service as a historical transactions. And then the next step is it uses that state transition to determine the percentage of change value of the measure of the host. So which means it checks the last 21 checks, and then next checks it actually compares the difference, like the percentage of the changes that's been happening. Then it actually compares the percentage. So if you see a host or a service is determined to have started flapping when its present state change first exceeds the high flapping threshold. So there's a period that actually there was a flapping happened, so it stores that flapping information. So the current state, if it actually exceeds the flapping state, then the service is determined to be unflapping. But if it is not, then it's not flapping. So it's actually the mechanism that actually Nagios uses, right? And the next thing is a host or a service determined to have stopped flagging when its percentage state goes below the flapping threshold. So there's a flapping threshold determined by the first 21 checks, and then it actually Nagios will actually compare with that value to determine whether it is flapping or not flapping, right? All right, so before we go to the next topic, I'm going to take a few questions here. Which is better, Nagios or Splunk? See, Nagios is widely used and has a very quite a lot of support, but Nagios is a little bit complicated to kind of install, to manage, so people use also Splunk. So I have actually extensively used Nagios, and it's actually a little bit tricky. You need quite a lot of expertise to work in Nagios, but Splunk, I think it's a little bit easier than Nagios. All right, so if you see the tools like OpenStack uses Nagios as a default monitoring tool. So it's very popular, and it's there from the very beginnings. That's why Nagios is popular nowadays. What are the containers? So here we have come to the containers and virtualization techniques. So virtualization pretty much everybody knows. So you have a big box like, for example, a blade machine with 20 processes, or let's say 100 processes and hundreds of GBs. You can split that box into multiple virtual boxes. So each project can be used independently of each of these virtual boxes. So each virtual server requires some kind of a resources, like it requires a memory, it requires a CPU, it requires a disk space, and etc. So that we know about the virtualization. But what is containerization, right? What is containers? Now containers consist of a kind of a runtime environment of an application, right? And all its dependencies, libraries, binaries, configuration files, and everything bundled into one package. Now, containerizing an application platform and its dependencies removes the differences in OS distribution and underlying infrastructure. That's a definition. Let me explain this, very quickly. Now, if you, for example, wanted to run, if you have only one box and then you want to run an application that actually runs on Ubuntu. So let's say you're using Red Hat Linux and you have a host machine, but you want to run a small application like HTTP on a Ubuntu box. Now, in the native way, you have to install, you have to create another separate server called Ubuntu and then run it, and that requires resources, memory, and then separate virtualization, virtual box. But using containers are lightweight applications that provides a runtime environment for your host. For example, you can install a container called Ubuntu to run your Apache in your host machine itself. So they are very lightweight, and they don't need separate virtual boxes. You can run it on your own box, all right? And all you need is a container engine running on your host box. The container engine will actually needs to be installed on your host box, and that actually, where on top of that you can actually start multiple containers, and each container has its own runtime environment, its own runtime variables, its own runtime Linux kernel, and so forth. So how this is possible? It's possible through something called a bootloader. Now, if you see the images of the container, they are pretty small, like 10 MB or maybe maximum 100 MB. But whereas you see a virtual box, it's actually can be up to 500 MB to several gigabytes, right? So that's why containers are very, has only essential information to boot that application and provides a separate runtime environment and can be run on independently on the same box. So for example, you can run app1 binary on the same box and app2 binary on the same box and app3 with separate binaries and libraries on the same machine. So actually used for microservice purposes. The next question is, imagine a scenario where large application is broken into small composable pieces. Of each of those pieces have their own set of dependencies. Let us call these pieces as microservices, right? So microservices are actually, you broke the application into small application which can be run independently and which has its own dependencies. And so you're actually breaking your large application into small microservices. And in order to run each of these microservices, what will you use? You use containers or virtual machines? So basically we use containers, not virtual machines. The reason is because if you use virtual machine, each virtual machine, you actually have to create a virtual machine for the microservice. So you have to need several virtual machines, which means you need a large CPU resource. You need to consume several lots of GBs of memory. But if you use containers, you don't need to extend anything. Your physical infrastructure can be as good as your laptop, where you can run a container for each your application, right? So each your microservice. So that's actually the advantage. And lightweight, doesn't use too much CPU memory, just runs only the service. If you install a virtual box, it runs so many services, but if you can observe a container, it only runs one service at the max, right? So let's see a difference, like write a Docker file to create an image into MongoDB. Let's observe this example, right? Docker file is actually storing all your information about your container in a particular file. So when you actually start this Docker file, it'll create a new container with all the rules that you have defined in this Docker file. So actually what you're doing is you're actually, the first thing always in a Docker file is from Ubuntu, from, and then the image, the base, we call it as a base image. So the base image can be Ubuntu, can be Red Hat, or can be AP Linux, or Alpine Linux, or it can be a Windows. Nowadays we have Windows Ubuntu. So they are very lightweight, small images stored in something called either a Docker Hub, which is actually a public registry of where all Docker images are stored. So when you do from Ubuntu, first this actually pulls the Ubuntu small image into your host machine, and then it actually runs various other commands that you're actually defining. So here, this example, we're running a container, and that actually installs a MongoDB image. So let's see what it does. So first we are downloading Ubuntu image, and then we're updating, run apt-get update, we're updating. So maintainer is basically the name of the person who's the author of this image, right? Author of this container. And then we're run apt-get update. So you're updating your repository, and then you're actually doing run. Run is basically a command that we use to invoke any commands, like when you do run and then specify something that will be invoked on the image container machine, right? So run apt key adv. So this command will run, it actually installs a key, apt key into your repository. So the next thing is you're running echo deb http downloads in this URL, this 1010, and then you're actually piping it to one file called resource list MongoDB list. So you're typing this deb information into this file. So that's the meaning of that command. And the next thing is you are doing also the run apt-get update, which is actually updating your repository. And then finally you're installing MongoDB, called apt-get install -y MongoDB 10gen. And then you're creating a mkdir, and then you're exposing a port number. So this is important because if you don't expose a port, then your host machine where you're installing a container will not recognize this particular port, right? So for example, your MongoDB on the container runs with port number 27017, but that port number has to be exposed to the host machine so that host machine can recognize that port, right? And then you're actually running the CMD with -- port 27017, and then finally you're actually running an entry point. An entry point is basically the process that actually runs. So usr bin MongoD is the process that you're running. So if you run this particular Docker file, and that actually creates an image, right? So once the container is created, if you log into the container using execc and you go and run for the processes, you will see only one process called usr-bin MongoDB, nothing else. So which means it's a lightweight, right? So that's actually about the Docker images. Now the next question is, what is an example? Explain how Docker is used for SDLC. All right, this is an important question. So how you can use the Docker, right? So let's say you have an application you're running and that actually runs an HTTPD service, and then you have some contents for that HTTPD, like web application. And let's say you want to use Dockerize your application. What would you do? So you have a code, and you have defined the code, you copied it to your local desktop, or you actually stored it in a Git repository. And then in order to test this particular thing, whether it works or not, you can actually use the Dockerization mechanism. So you write a Docker file, and the Docker file will run, from to you say Ubuntu, and then you run the commands like apt get update and apt install httpd, and then you run a copy command that actually copies your code from your Git repository to the container, and then run your HTTP application. So that's a simple. So you can actually have a Docker file that is again in a Git repository, and then you actually have a Docker file now, you have a code, and then you can actually integrate that with the Jenkins. So the Jenkins actually, once the build is done, it actually runs the Docker file that creates a container, and that container can be tested again. It can be a testing container, and that can be tested. You can write some tests, Selenium tests, to kind of test whether it's working fine or not. And you can run the exactly same thing to kind of just to same Docker file you can use with your code to spin up staging and production environment. So the exact same thing will be open. So for example, you have a host machine like production host, and you wanted a new container. So simply run the new Docker file, and that actually spins up a new Docker container. So that's easy. It's actually used for continuous integration, right? So that's about SDLC and how Docker provides a consistency computing environment through SDLC. So we have actually seen, I've already explained a little bit about it. So let's say you have a project code, and then that actually has a Docker file, and Docker file actually has a Docker image, and then the Docker container, and the Docker image actually pulled from a Docker hub, for example, from Ubuntu actually pulls the image from the Docker container, right? And then spins up a Docker container. And if you run this code Docker file, you can actually start a server, right, in a staging. Same thing actually can be started on the production server. So it's exactly the same type of source that you're taking to build a container. So source is same, and so the consistency should be processed, right? Then the next question, probably I think this is the last, it's about what is Docker Compose. All right, so actually one container can have a multiple, you can use the Docker Compose file to kind of deploy several containers, right, in one single Docker. For example, what we have seen, just an example before, a Docker file is about one container. But how about you wanted to store multiple containers? And then we use the Docker Compose. Now Docker Compose uses YAML, yet another markup language, where you can actually define multiple Docker files, right? The copies of the Docker files, whatever you have mentioned, the Docker file. Similar thing you can mention, like you can have a few lines of code for to start your web application container, and then to Postgres database container, and then Redis cached container. So these three containers can be together locked up in one Docker Compose file, and then you run Docker Compose that actually spins up 3 different containers with one single command. So that's actually so you can run these 3 containers with a single command using Docker Compose, right? So you need to install Docker Compose for that one into the box. So before I can actually continue, I just want to take a look at the example. So suppose there's a question says, suppose if I need a LAMP stack on my nodes, so I can use tools Chef, Puppet, and to do that. So the question is, my understanding is you want to start a LAMP stack on your node, and then what would you use Chef or Puppet? You can actually use any of these to start LAMP stack. So what you need to do is for LAMP stack, you need Linux, which obviously is your application, and for example Apache or Nginx, and then MySQL, and then PHP. You want to install all these things. You can write for example, if you're using Chef, you can write a cookbook to install package like dependent packages in one single cookbook, and then run the cookbook against that particular node, and that actually installs the LAMP stack. That's actually a good example. Okay, the question is, but at the same time, I can write a Docker file to upload it on the Docker Hub so the teams can pull the image and build the containers. That's right. So in both cases, I can easily deploy LAMP stack. Yes, you can. So with the Docker file, as we can see, it's like lightweight. You can have a single container image for all your LAMP stack together, right? Using Docker. You can create your own Docker image, right, that has a LAMP stack in it. And there are actually examples in the Docker Hub, right? Or that's actually lightweight, right? Now, not every application can work on a lightweight. It requires you probably have a dedicated server called for Apache, a dedicated server for MySQL, a dedicated server for your PHP running. So in that case, and they are available already, you're not changing those servers, you're not provisioning everything, it's provisioned already. And there are physical boxes like the virtual boxes. In that case, you use Puppet or Chef to manage these dependencies and the installations, right? So that's the difference. When I use Docker, why I need tools like Puppet and Chef? Actually, if you use Docker in this instance, well, there's less. You don't need to do much with Chef and Puppet, but Chef and Puppet actually can be used to kind of for provisioning altogether a brand new server. So basically, if you're running a Docker image, you don't need actually a Chef or Puppet for that one. But in order to run the Docker image, you are probably running on a host machine, and that host machine should have all the installations to be done. It should have a Docker engine running. It should have a prerequisites like probably Git is running, because you are probably running Docker file that actually copying stuff from your Git image. So for that purpose, you use Chef and Puppet. So Chef and Puppet or any other configuration management tool together with Docker actually gives us the best result, right? Because we are not just talking about running a small container on a box, talking on an entire enterprise-wide, how you do it. So Chef and Puppet has its own purpose, Docker has its own purpose. You combine them together, right, to kind of make it as a more enterprise-wide, practices. So that okay. The next thing is, before I end up this question, I just wanted to show you what the summary of the sessions. We have actually seen the generic DevOps questions, and then we've seen the source code management using Git, and then we have also seen the continuous integration best practices, and also the using a little bit about Jenkins, and we have seen the configuration management, push and pull mechanisms, and difference between various configuration management tools like Puppet, Ansible, and Chef. Continuous monitoring, we have actually seen what is NRP and how does Nagios work. And we've also seen containerization, an example of Docker file, and then Docker Compose. The difference between Docker Compose and Docker file is it's basically a Docker file. You actually run one container. You can combine multiple containers into one single Docker Compose and run it using Docker Compose. So the next question is DevOps introduced in order to facilitate microservice architecture? Yes, it is. It's not actually just introduced to facilitate microservice architecture. It's actually introduced to see, when DevOps was introduced, it was introduced when these popular concepts about configuration management and infrastructure as code has started, right? Microservices is like modern architecture, and without DevOps, you cannot have microservice architecture. That's for sure. But introduction of DevOps is not just for microservice architecture, but also for normal architecture, like all the service-oriented architectures that we already have with many organizations. So whether you use microservices or not, DevOps is still a requirement for agility and for the quality of your releases, right? And for microservices, it's like a must, a mandatory one. All right, so do you guys have any other questions? If you have any questions, feel free to post, or if you have any feedback that you wanted to give it to us, I will spend a few more minutes to answer. I know I've answered all their questions, while running this webinar, but if you still do have any questions, I'll give you a few more minutes. You can post them, then I'll try to answer them. So I assume that there are no questions from people. So thank you very much for joining this session, and I hope you have, learned something. Myself, I've learned something as well from the questions you guys have posted. Thank you very much, and hope to see you soon. Bye-bye.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!